Okay, I hope you have the sound on and that you remember that you need to use these notes whenever you do homework and when you do classwork. This is not to be hidden away and, oh, yeah, I have some notes. Use these and use them when you ask questions and keep them handy. This is for you to find inverses of functions and of inverse relations. These are maps, so this goes into your vocabulary that you have up here. We're not going to do the composition of functions. That doesn't even show up here in your notes. The whole point of inverses, a function and its inverse, the domain and the range switch places. So you can replace the domain with the range, and then you have your inverse. So if you look at these maps, take this function. You take a look at your domain values. They are paired up with these range values. It's kind of like having ordered pairs. So -2, -4, -2, that is an ordered pair. 0, -3, 1, 2, 4, 1. So those are ordered pairs. You can see them in the map. The inverse of this function, the domain, which was the range of the function, that is the domain of the inverse. So since you can see the domain and range values of the function, the original function, the domain for the inverse, its range values come straight from the domain of the function. So if you have a domain of -2, look back at your original function. What was -2 paired with? It was paired with -4. So that is what -2 as the x value in the inverse, its y value is -4, just going straight from the function itself. So using that as a clue, -3 for your inverse. If the y value in the function was -3 and the x value that it was paired with was 0, then the y value of the function for -3 is 0. And keep on going down the line. So if 2 was the y value in the function and its x value was 1, then 2 is the y value in the inverse. It's the x value in the inverse. Its y value is 1. So these just switch places. So you put this in the x position, put these in the y position. So they just switch places. They are backwards. Same thing with this function b. So you have b and you have a on your worksheet. So this function, here are the domain values, 4, 0, 1, 4. You see them as your y values in the inverse. Here are the y values of the function. You see them as the x values in the inverse. So here's this question about, is the inverse itself a function? The definition of a function is that all the domain values are unique. There was this vertical line test. So if you had all these points graphed, if you drew a vertical line through those points, would that vertical line touch 2 points? So would the x values be the same? So if you look at all these, is there more than one y with an x value? No. You've only got one y with one x in this function. And the same with its inverse. So there's one single y for one single x, one single y for one single x. So this is a function. Every domain value, every x is completely different, completely unique. If you look over here, so the function itself was an inverse, or excuse me, the function itself is a function, would pass the vertical line test. Every x value is different. So if you look at each y value, has an x. Here's the y value, it has an x. This y value has two different x's, but if we wrote these as ordered pairs, you'd have -4, -2, 0, -3, 1, 2, 4, 2. So there's no x's that repeat. If you wrote that out, you could see it. However, when you look at the inverse, and if you write these out as ordered pairs, it's pretty simple to see. You see that these 2 points here, the x values repeat themselves. They are not different. You have a -2, you have -3, you have a 2 and a 2. So not unique. They are not different. If you look at this graph, and you guys will need to fix this. There was a typo. This had an A1. If you look at this graph, you had the black points already here. And if you take their inverses, remember the key was that the x and y values switch places. So if we write the inverse of this, you just switch the x and y coordinates. So 1, 2, the inverse is here, 2, 1. 4, 1, the inverse is here, 1, 4. So the y coordinate
The x-coordinate becomes a y-coordinate. Y-coordinate becomes an x-coordinate. Very simple. -4, -2. This is when I told you how to typo. So -4, -2, that was this point right here on the graph. Its inverse is -2, -4. That is right here, -2, -4. 0, -3. Its inverse is -3, 0. And that is it written. So when you're answering this question, what do you observe about the graphs of the function and its inverse in relationship to the line y equals x? This is our linear parent function. It just goes through the origin and has a slope of 1, up 1 over 1. It's called the identity function. It acts as kind of a mirror. So if you look at -4, -2, if it had a mirror image, it would be -2, -4. So it's inverse. And the same thing with our 0, -3. It has a mirror image at -3, 0. So the same thing with all of these points. It has a mirror image right across this identity function. And that's pretty much it. So because those x and y values switch places, they reflect across this diagonal, this y equals x. I didn't capture those steps. You have the 4 steps written above you. So the first thing it says to find an inverse is this function notation just means y. That f of x means y, a function of x. So when you have an x value, it's in your function, it is acting as y. So what does x do? It gives you y. So just rewrite this. Function notation, it means y. Your second step, which might have several, solving for x. So we spent that time solving for y. Same thing, I'm getting x by itself. So I need to move the 4 over. To cancel it out, I have to subtract in this case. Then I will need to get this x totally by itself. It's being multiplied by 3. I have to divide by 3. Dividing everything over here by 3. The y and the 4. So I have y over 3 minus 4 over 3. My x is totally by itself. This step right here goes back to that inverses, the x and the y's flip places. So the only difference between this right here, where x is by itself, and this right here is I just switched the x and y in their places. Instead of it being y over 3, it says x over 3. Instead of saying x equals, it says y equals. That's all I did. Switch their spots. So x, I put over 3. And I put y right here. That is all I did. No math, no proof, no nothing. I switched their spots. And then on the very last step, all we do is put some function notation back in here. It has this -1 to say, I found my inverse. We are going to graph in your homework. We're only going to graph lines. We're going to practice some more. So you're going to practice slope and y-intercept. So you're going to start at 4, right here. We're going to go up 3 over 1. So up 1, 2, 3. Okay, I gave you a terrible coordinate point. Whatever. Up 3 over 1. We can also go down 3 and to the left 1, because down and left, that's negative, negative, so it gives you a 4%. So here's our original function. Something you can do is, because this is kind of no fun to graph, I did graph that. I did 4 over 3. You can change that to a decimal, 1.3. So I graphed 1.3, and I went up 1 and over 3. So no fun. We will talk about graphing this. You can do the inverse of this 4. This is 0, 4. So I could graph 4, 0 to lay on my line. And I could also take one of these points and I could inverse that. So this ended up being over 1 and how much? 7. So 1, 7. So I can reverse that and go over 7, 1. Now I have 2 but we'll practice that more tomorrow. So you need to have these finished. You must have them with you. You can go through these points and